So this video will review lesson 22, finding the percent of a number. And when I talk about this number here, what I'm really talking about is finding the percent of the whole. So if I remember that a percent is going to be a part to whole ratio where the whole is going to be set to 100. So it's going to be the percent to 100. So in these problems, I'm going to have the whole and the percent, but what I'm going to be looking for is going to be the part here. Now there's two ways that we're going to be doing this today. The first is finding the percent unit rate, and the second one is looking at the percent relationship to the whole. Okay, so the first one, finding the percent of the unit rate. Let's start off with what is 35% of 80. So to make sure I understand this, I'm just going to draw a model. And I'm going to have the top part of this represent my percent and the bottom represent my quantity. Now, if I want to know what is 35% of 80, that tells me that the total that I'm going to be looking at and for comparison is going to be 80 here, which 80 is going to be my 100%. And what I'm going to be looking for is 35%, which would be somewhere around maybe here. 35%, and I am looking for what is that over here. Now, I'm also going to draw a ratio table. I'm going to do this two ways simultaneously so that we make sure that we understand. So I'm just making that table with quantity here and percent here. I know that the relationship that I have is 80 is going to be equal to 100%, and what I'm looking for is 35%. Now, when I think about how do I get from 100 to 35, that number might not come up naturally to me. But anytime we get into that scenario when I'm working with ratios, remember we can always go to our faithful the unicorn unit rate. Okay, so I know that I can get from 100 to 1, and then from 1 I can get to any number that I need to. So I'm going to multiply this 100 by 1 over 100, which remember is the same as dividing it by 100. And if I do that, I need to do that to the other side. Now, what does this mean when I'm looking at the actual picture? What I'm finding is that this is 80 over 100. What am I actually doing here? So when I'm doing that, what I'm actually finding is the unit rate of my percent. So going back to my bar model, this is 100% here. And if I wanted to figure out what 1% of, I would need to divide this into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all the way up. And we're just going to, obviously I'm not going to sit here and try to perfectly divide this up. But basically what you're going to assume is that there are 100 pieces here because I'm taking that 100 and I'm going to divide it up 100 times. So 80 over 100 can be rewritten as 8/10 or 0.8. So I know that if I get that one little section, which is 1%, so over here we have 1%, that's going to be equal to 0.8. But I don't want one of them. I want 35 of them. I'm going to multiply this side by 35, my percent by 35. But if I do that, I have to multiply this side by 35. And I'll get, which 35 times 80 over 100 is going to give us 28. So we know that 28 is 35% of 80. Now, let's just go back up to our model really quick and show that again. So remember, we found 1%, which was 0.8, and then we wanted 35 of them. So we're going to take that 0.8 and we're going to multiply it times 35. And when I do that, I get 28. So I know that 28 is 35% of 80. You might be thinking, why did I leave this as that expression and I didn't go and change it? I didn't simplify it every time I put in a new operation or a new part of the equation. And the reason is because I want to look back up at this in just a minute. Now, this whole process can be generalized. If I think of this instead of with my numbers, I'm going to think about it just more abstractly in just terms. Because what I want to do is find a rule that works with this. So if I look at this, if I say, instead of saying what is some percent, I'm just going to say percent. So instead of saying 35%, I'm just going to say a percent. And instead of saying 80 as my whole, I'm going to say a total whole. So same bar diagram. And now I'm going to put the whole down here and set it equal to 100. And then I'm going to put my percent here, but it really doesn't matter where I put it. It just matters that I have it somewhere on there because this process is going to be the same. Okay, so setting up my ratio table. The first part that I know is going to be just like over here, how I knew my whole was going to be equal to 100. Same thing over here. My whole is equal to 100. I'm going to divide both sides by 100 so that I can get my unit rate of 1%, which will tell me that 1% is going to be whatever that whole number is, I'm going to divide it into 100 pieces. So if I divide up here by 100 pieces, I'm going to end up with 1 of the 100 is going to be 1%. But in order to get that, I have to take my whole and divide it also by 100, which is what is here. And then whatever that number is, I've got to multiply it by however many percents I have. So multiplying it by percent, and I get the percent, whatever it is, times the whole over 100, just like I have it over here, the percent times the whole over 100. Now I can see my rule, and my rule is going to be to find the percent of a number, I take my percent and I multiply it times the whole over 100. So a quick example, what is 32% of 50? I'm going to go back and I'm going to remember that the percent of a number is equal to the percent times the whole times 100. So this would be the percent times the whole over 100. And then I can simplify this, and I know that 50 over 100 is just 1/2. So in this case, I'm looking for 1/2 of 32, which is 16. So I know 16 is 32% of 50. Okay, now the other one doesn't take quite as long. There's not as much to explain, so let's go to the other method. So the other way to think about this is like the percent relationship to the whole. So in class, we talked about a store and its business plan and how it's set up for each one of the items that it sold, that a different percentage would go to different things. And the main thing was that we said that for each one of these items, when it was sold, that 56% would go to inventory. So that's what we're going to be looking at. So let's start off with some simple numbers so we can really understand what's going on here. So if I think about a dress that's going to be the price of $100, so those numbers make it easy to see, right? What's going on and to be able to see the relationship. If I have $100, well, and I'm looking at percent, I know that 100 is going to be 100. So if I'm looking for 56%, well, then I know that that's just going to be $56. Okay, that one makes sense. So let's try another one. What if I have a sticker that's going to be $1? And we can think about this as, well, this is really similar actually, because we talked about in class how if you have a dollar, that there's 100 cents in each dollar. So then when looking at this problem, I'm not looking at $100, but 100 cents. I'm looking for 56% of 100 cents or $1. Well, then 56% will just be 56 cents. Now, let's say that I have let's say a pack of gum. Then it would make sense to say, well, if I'm making my total price go up by 2, then the 56%, what 56% would be, would also go up by 2. And if I had a candy bar that was going to be $3, well, then that would just be scaling this one up by 3. So then I could also scale this one up by 3. Matter of fact, I could just start thinking about this as 56 cents for every dollar, which if I wrote in fraction form would be 56 hundredths for every dollar. Now, let's say that I have a shirt that's $34 and I want to find 56% of it. If I think of this as 56 cents for every dollar, then I could just calculate this by taking 56 hundredths times 34 and getting $19.04. Now let's just double check our reasoning here, and let's go back up really quick to our dress problem and see if the same thing works. So if I want to have 56 cents for every dollar and I have $100, we want to double check that I'm still going to be getting that 56%. So if I have a dress that is $100 and I know that it's going to be 56 cents for every dollar and I have 100 of them, if I multiply this together, I'll get 5,600 hundredths, which can be simplified to 56 again. Now, going back and let's think about this logically for a second, and let's see if we start to see the reasoning behind this and we can generalize it into its own pattern. Remember that the definition of percent is that it's the percent is the number per every 100, so for every 100. So if it's for every 100, then if I want to find the percent of my total, or the part in my ratio, then I'm going to take that percent for every 100, but I need to take it out of the total. Which, remember, when we're thinking about multiplying fractions, remember we've been practicing this, that when I multiply by a fraction, I can almost think of this as that multiplication as of. So this would be the percent out of 100 of the total. And so now this comes to our second rule. So now going back and using this in an example quickly. So if we want to find what is 32% of 50, I'm going to this time think of it as if I want to find the percent of the total, that's the percent of my total. And so looking at my numbers, this would be 32 over 100 times 50, where 50 is my total and 32 is my percent. I want to think of this as 32 hundredths. So I have 32 hundredths, but I'm going to do this 50 times. So if I take 50 32 hundredths, then I will get 1,600 hundredths, or 16. Which, that's a good thing that we got that answer, because if we go back to our previous problem using the alternate way of doing it, so say problem, what is 32% of 50? What is 32% of 50? I got 16 here and 16 here. Okay, so in summary, to find the percent of a number, or the part in the percent proportion, there are two different methods. The first one's going to be to take the whole over 100 times the percent. And the second one is you can take the percent over 100 times the whole. And what you'll find is that these become useful. If I go back to this is the last thing I'm going to say. Sorry, I know this one is super long, so I do apologize. I do want you to look at the two different ways of the formula. Which one would have been easier to calculate? If I think of this as 32 times 50 over 100, where I realize that 50 over 100 is just saying half? Or is it easier to take 32 hundredths times 50? And so it's useful to know that these are interchangeable and I'm not just stuck to one way of calculating. That is it for this lesson. Sorry, I know that was a really long one, but there was a lot of information to get in there. So